Hello there, and welcome to the Sleepy Nature channel. Tonight, let yourself sink into something soft and luminous. Take a slow breath in, and as you breathe out, feel your shoulders dropping just a little. We're going to drift together through the gentle world of rainbows, those quiet arcs of color that appear when light and water meet in perfect, peaceful harmony. There's no rush here, just you breathing slowly and the whisper of color spreading across the sky. A rainbow begins with something so simple, a single ray of sunlight traveling through space. That light has journeyed for 8 minutes and 20 seconds from the sun, crossing the vast, quiet darkness, just to reach the rain near you. When it arrives, tired from its long voyage, it meets a droplet of water hanging in the air, and something beautiful happens without any effort at all. Inside that tiny droplet, the light bends. It doesn't break or shatter. It simply curves, like a river finding its way around a smooth stone. White sunlight, which looks so plain and ordinary, is actually holding 7 colors close together, traveling as one family. The droplet gently pulls them apart, and suddenly red separates from orange, yellow from green, and all the colors, remember, they are individuals. You can imagine this happening in 1,000,000 droplets at once, each one no bigger than the tip of a pin, all hanging weightless in the air after the rain. Each droplet is doing the same quiet work, bending light, separating colors, sending them back toward your eyes. And because there are so many droplets, all those colors line up perfectly, forming an arc across the sky. The rainbow you see is always exactly 42 degrees away from the shadow of your own head. It's a private thing, in a way. If someone stands beside you, they see their own rainbow, made by different droplets, at a slightly different angle. Your rainbow belongs to you, painted by water and light in a place only you can see from where you're standing. Red always appears on the outside of the rainbow's arc, and violet always curves along the inside. This happens because red light bends the least when it enters a water droplet, so it takes a gentler path. Violet bends the most, curving more sharply, and settles into the inner band. Between them, orange and yellow and green and blue and indigo arrange themselves in perfect order every single time, without anyone directing them. Sometimes, if you're lucky and the light is just right, you might see a second rainbow floating above the first. This one is softer, more ghostly, and its colors are reversed. Violet on the outside now, red on the inside. It happens when light bounces twice inside each water droplet instead of once, taking a longer journey before it reaches your eyes. The double reflection makes the colors flip like a mirror image of the first arc. Between the two rainbows, if you look closely, there's a darker band of sky. This space is called Alexander's Band, named after a man who noticed it over 2,000 years ago. The sky there seems dimmer because that's where the light doesn't reach in quite the same way. It's a place of gentle shadow between two curves of color, a resting space in the sky. Rainbows appear most often in the late afternoon, when the sun is low and rain showers are drifting past. The sunlight comes in at a shallow angle, perfect for creating that 42-degree curve. Morning rainbows are just as beautiful, appearing in the west, while the sun rises behind you in the east. But people see them less often because we're not always watching the sky at dawn. You don't need a storm to see a rainbow. Just a little rain and a little sun, both present at the same time. Sometimes a quick summer shower passes through while the sun keeps shining, and the rainbow appears almost immediately, like the sky is offering you a gift for noticing the beauty in mixed weather. Waterfalls create their own rainbows. If you stand near falling water on a sunny day, you'll often see small rainbows forming in the mist. These don't need rain clouds, just the water breaking into tiny droplets as it falls, and sunlight passing through. The rainbow might hover right there at the base of the waterfall, small and steady, as long as the sun and spray remain. Garden sprinklers make rainbows too. On a summer afternoon, when you water the flowers or the grass, you might turn and see a little arc of color floating in the spray. It's the same physics as the sky's rainbow, just smaller, more intimate. You can walk right through it if you want, feeling the cool mist on your skin while colors shimmer around you. Rainbows are circular, not just arcs. We see them as half circles because the ground blocks our view of the bottom half. But if you were high enough, in an airplane perhaps, or on a mountain looking down at rain in the valley, you might see a full circle of color hanging in the air, complete and unbroken, with no beginning and no end. Moonbows exist too, formed by moonlight instead of sunlight. They're rare and faint, appearing only when the moon is bright and full and rain is falling in the night. The colors are there, all 7 of them, but they're so soft that human eyes often see only white or pale silver. A camera with a long exposure can capture the colors, revealing what was there all along, just too gentle for our eyes to detect in darkness. Some cultures see different numbers of colors in the rainbow. The 7 we name, red, orange, yellow, green, blue, indigo, violet, were chosen somewhat arbitrarily. The colors blend into each other so smoothly that you could name 5 or 6 or a dozen. Nature doesn't draw hard lines between orange and yellow. We do that with our words. Indigenous peoples in different parts of the world have their own ways of understanding rainbows. Some see them as bridges, some as serpents, some as promises or pathways. But almost everywhere, people find them beautiful. That seems to be universal, the human response to seeing color arc across the sky after rain. A rainbow is always opposite the sun. If the sun is behind you, the rainbow appears in front of you. If you turn around to look at the sun, the rainbow vanishes from your sight. It exists only in that specific relationship. Sun behind, rain ahead, you in the middle, watching. The colors you see are made entirely of light. There's nothing physical there to touch. If you tried to walk toward a rainbow, it would move away from you at exactly the same pace, always maintaining that 42-degree angle from your shadow. You can't reach it because it's not really a thing. It's an event, a moment of light doing something beautiful in cooperation with water. And yet, for all its physics and angles, a rainbow still feels like magic. Even when you understand how it forms, even when you know the science, seeing one appear still makes you pause. There's something in us that responds to that arc of color, something that quiets and softens, something that says, the world can be beautiful without trying. So, breathe slowly now and imagine a rainbow appearing after rain. The sky is clearing, the sun is warm on your back, and there it is, red and orange and yellow and green and blue and indigo and violet, all hanging softly in the air where water and light have met. You're safe here, watching colors bloom in silence. The air smells different after rain, and that's when rainbows come. There's a word for that smell, petrichor, but you don't need to remember it. Just know that when rain touches dry earth, tiny particles rise up into the air, carrying the scent of soil and stone and growing things. You breathe it in, and somewhere in front of you, a rainbow is forming in the settling droplets. Rain doesn't fall in sheets the way it looks from a distance. Each drop is separate, falling alone, shaped like a tiny sphere by the surface tension of water. They're not teardrop-shaped, despite what we draw in pictures. They're round, or slightly flattened by air resistance, tumbling through the atmosphere at their own pace. When sunlight meets them, each one becomes a tiny prism, a small miracle of refraction. The drops catch light at different moments as they fall. One drop might send red light to your eyes, then fall a little farther and send orange to someone else. Another drop takes its place, continuing the pattern. The rainbow looks still and steady, but it's actually made of constantly changing drops, each one flickering through the arc for just a fraction of a second before falling past the perfect angle. You've probably noticed that rainbows appear more vibrant when the background is dark. Against a gray rain cloud, the colors seem to glow. That's because your eyes are comparing the brightness of the rainbow to the darkness behind it. The colors themselves don't change, but your perception of them does. They stand out more, feel more vivid, more alive against that soft charcoal sky. Sometimes only part of a rainbow appears, just a fragment of the arc, floating in a clear patch of sky, where rain is falling, but elsewhere the clouds have moved on. These partial rainbows have the same beauty as full ones, maybe more, because they feel more fleeting. They remind you that all of this is temporary: the rain, the light, the color, the moment. The brightest rainbows appear when the raindrops are all similar in size. If a shower contains a mix of large and small drops, the rainbow becomes hazier, less defined. But when the drops are uniform, all falling from the same cloud, formed in the same conditions, they bend light in almost identical ways, and the colors align more perfectly, more clearly. In the tropics, rainbows appear more often than in other places. The afternoon rains are frequent and brief, and the sun is strong. The combination creates ideal conditions almost daily during certain seasons. People who live there grow up with rainbows as a regular presence, not a rare surprise. The sky offers color the way some places offer snow or fog, routinely, generously. Arctic rainbows are low and wide because the sun stays close to the horizon for much of the year. The angle creates rainbows that seem to stretch across the entire visible world, enormous arcs of color hovering just above the tundra. In the extreme north or south, you might see a rainbow at midnight during summer, formed by the sun that never quite sets. Frost rainbows exist too, though they're extremely rare. They form in tiny ice crystals hanging in the air on very cold days, usually near sources of moisture like hot springs or waterfalls in winter. The ice bends light just like water does, creating delicate arcs of color in freezing air. People who see them often think they're imagining things. Color appearing in winter feels unexpected, out of place, like a gift from a season that usually deals in white and gray. Light takes the most efficient path it can through a water droplet. It enters, bounces once off the back inner surface, and exits at an angle that sends it toward your eyes. This path is called the path of least time, and nature seems to prefer it. Light doesn't wander or explore. It knows in its own wordless way the quickest route from sun to rain to you. If you see a rainbow over the ocean, it might seem to touch the water at both ends, creating the illusion of a bridge from wave to wave. Sailors throughout history have watched these ocean rainbows and wondered what it would be like to sail beneath one, to pass through that curtain of color. But of course you can't. The rainbow moves with you, always at the same angle, always just out of reach. Rainbows don't cast shadows. They're made of light itself, so there's nothing to block other light. You can stand in what feels like the path of a rainbow, but it won't create darkness anywhere. It only adds brightness, only contributes color to the world without taking anything away. The violet edge of a rainbow is harder for some people to see than others. Our eyes are less sensitive to violet light, and some people's eyes are more sensitive than others. If you have trouble seeing the violet band, that's normal. It's there in the physics of the light, but your biology might not register it strongly. You're not missing anything important, just a shade at the edge of perception. Some rainbows seem to glow more intensely than others, and this happens when the sun is very bright and the rain is very pure. Clean water droplets with no dust or pollution inside them refract light more efficiently, creating more saturated colors. After a storm that has washed the air clean, the first rainbow that appears can be breathtakingly vivid, every color distinct and strong. Airplane passengers sometimes see cloud rainbows, circles of color formed in the mist of clouds below the plane. These look like halos or rings, complete and perfect, and they often surround the shadow of the airplane itself. It's a strange and beautiful thing to see. Your own shadow, ringed in color, floating on a sea of white cloud. You can create a rainbow with a glass of water and a piece of white paper. Hold the glass up to sunlight coming through a window and tilt it until the light passes through the water at the right angle. The rainbow will appear on the paper, small but perfect, with all 7 colors in order. It's the same principle as the sky's rainbow, just scaled down to fit in your hands. Dewdrops on spider webs sometimes create tiny rainbows in the early morning. Each drop acts as a prism, and if you crouch down and look closely, you might see miniature arcs of color clinging to the silk threads. The spider doesn't know it has decorated its web with light, but you can see it if you're paying attention, if you're moving slowly enough to notice. Some gemstones create rainbows when light passes through them. Opals in particular seem to hold color inside their structure, flashing red and green and blue as you turn them in your hand. This isn't quite the same as a water rainbow. It's caused by the way light diffracts through microscopic spheres of silica inside the stone. But the effect feels similar, color appearing, shifting, dancing in response to light. Light pollution makes rainbows harder to see in cities, not because it affects the rainbow itself, but because it reduces the contrast between the rainbow and the sky. In a place with dark skies, a rainbow stands out sharply. In a city, the sky is already brightened by artificial light, and the rainbow's colors have to compete with that ambient glow. They're still there, just harder for your eyes to distinguish. Ancient people tried to explain rainbows without understanding refraction, and they came up with beautiful stories. A bridge for gods to descend to earth, a serpent drinking from the sea, a promise that floods would not return. These stories aren't wrong exactly. They're just different ways of holding wonder, different languages for talking about the moment when color appears in the sky without warning. And when you see a rainbow, you're seeing something that has been appearing on Earth for as long as there has been rain and sun. Dinosaurs saw rainbows. Early humans saw rainbows. Every generation of every species with eyes capable of seeing color has had the chance to witness this exact same phenomenon, created by the exact same interaction of light and water. So when a rainbow appears for you, you're part of that long, long chain of witnesses. You're standing where countless beings have stood, looking up, seeing color arc across the sky, feeling something shift inside, something quiet, something like peace. Breathe slowly. The rainbow is there, in your mind, in the space behind your eyes, where memory and imagination blur together. Red and orange and yellow and green and blue and indigo and violet, all present, all soft, all waiting for you to rest in their gentle light. The light that forms a rainbow has traveled so far before it reaches you, from the core of the sun, where hydrogen atoms fuse into helium. Photons of light begin a journey that takes thousands of years just to reach the sun's surface. They bounce and scatter through layers of dense plasma, slowly working their way outward. When they finally break free into space, they speed toward Earth, and 8 minutes later, they arrive. Some of that light will pass through the atmosphere without touching anything, but some will meet rain, and some of that rain will bend the light just so, and some of that bent light will travel at exactly the right angle to enter your eyes. The probability of any single photon making that complete journey, sun to rain to you, is vanishingly small. And yet, it happens constantly, millions of times over, creating the rainbow you see. Water droplets in the air are remarkably uniform in how they bend light, despite being created by chaotic processes. A raindrop forms around a tiny particle of dust or pollen high in the atmosphere. Water vapor condenses around this nucleus, molecule by molecule, until the drop is heavy enough to fall. Different drops form around different particles in different parts of the cloud, but they all end up bending light in nearly identical ways, which is why the rainbow's colors line up so precisely. The space between raindrops is mostly empty air. When you look at falling rain, you're seeing thousands of drops, but the space between them is vast compared to their size. Each drop is a tiny sphere, maybe a few millimeters across, falling through meters and meters of emptiness. And yet, collectively, they form a continuous arc of color across the sky. Emptiness and fullness working together to create beauty. If rain is falling very heavily, the rainbow might appear dimmer. Too many droplets in the air start to scatter light in random directions, disrupting the clean paths that create vivid colors. A light shower, with fewer drops spaced farther apart, often produces the brightest rainbows. There's an optimal amount of rain for rainbow making. Not too much, not too little, just enough. Sometimes you can see your shadow in the rain while looking at a rainbow. Your shadow falls on the curtain of rain itself, a dark human-shaped silhouette against the gray. And around the shadow of your head, the rainbow curves, as if you're the center of the display. This is called a glory or a Brocken specter when seen in clouds. But the same effect can happen in rain. You, small and temporary, at the center of a circle of light. the temperature of the air affects how long raindrops stay suspended. In warmer air, drops evaporate faster, shrinking as they fall. In cooler air, they maintain their size longer. This can change the quality of the rainbow slightly. The size of the droplets influences which wavelengths of light are emphasized. A rainbow on a hot summer day might look subtly different from a rainbow on a cool autumn afternoon, though you'd need sensitive instruments to measure the difference. Rainbows have inspired so much art over the centuries. Painters have tried to capture them, though paint can never quite match the luminosity of light itself. Pigments on canvas absorb light and reflect what's left. A rainbow is pure emission, pure color made of nothing but photons. Still, artists try, and in trying, they create something beautiful in a different way, a translation of light into matter, of physics into feeling. Children often try to find the end of the rainbow. There's a persistence to this search, a hopefulness. They know on some level that they can't reach it, but they want to try anyway. And maybe that's a useful instinct, the desire to move toward beauty, even when you know it will stay just beyond your grasp. Maybe chasing impossible things has value if it makes you run through wet grass under a clearing sky. The double rainbow, when it appears, always has a reversed color sequence. This happens because light bounces twice inside each droplet instead of once, and the extra bounce flips everything. It's fainter than the primary rainbow because some light is lost with each bounce, absorbed by the water or scattered in other directions. What remains is softer, more pastel, but still clearly there if you look for it. Between the two rainbows, that darker band of sky called Alexander's Band, you can sometimes see stars starting to appear if it's near dusk. The darker sky provides just enough contrast for bright stars or planets to become visible, even though the sun is still up. It's an in-between place, not quite day, not quite night, suspended in a space of half-light and transitional color. Some birds fly through rainbows without seeming to notice. To them, it's just rain and air. They don't see it the way we do. Birds have different color vision than humans. Many can see ultraviolet light that we can't perceive. Maybe they see additional colors in the rainbow that we don't. Or maybe the whole thing looks different to them. We'll never know. Their experience of the world is their own, as private as ours. When a rainbow appears over a forest, the colors seem to hover among the treetops. The green of the forest and the green in the rainbow blend at the edges, creating a strange effect where nature seems to be reflecting itself, earth reaching up to meet sky. The trees stand dark and still, dripping with rain, and above them, light arranges itself into an arc. Grasslands show rainbows differently than forests. With no trees to provide scale or reference, a rainbow over a prairie can seem enormous, stretching from horizon to horizon, so large it feels like you're standing inside it. The grass bends in the wind, still wet, and the whole world smells like rain and earth and growing things. Deserts rarely see rainbows, but when they do, the contrast is startling. A landscape of brown and tan and ochre, then suddenly this explosion of color against storm clouds. Desert dwellers sometimes speak of rainbows with special reverence because they're so rare, so precious. Water itself is precious there. Water breaking light into color is doubly so. In snowy landscapes, rainbows are nearly impossible because rain doesn't fall when it's cold enough to snow. But occasionally, on the edge of a storm system, you might get rain and snow at the same time. And in that confusion of precipitation, a faint rainbow might appear. It's ghostly and strange, color in a monochrome world, lasting only minutes before the rain turns entirely to snow. Coastal areas see rainbows often because weather changes quickly near the ocean. A squall blows in, dumps rain for 10 minutes, then moves on, and the sun breaks through. The salt in the air doesn't affect the rainbow's formation. It's made in freshwater rain, not the ocean itself, but the proximity to all that water creates frequent opportunities for the right conditions. Some mountains seem to collect rainbows. Peaks that force air upward create localized rain showers, and the elevation means you're often looking down at rain falling in valleys below while standing in sunshine. From that vantage point, you might see full circular rainbows, or multiple rainbows at different distances, or rainbows that appear and vanish as clouds shift across the landscape. Islands see rainbows from all angles. On a small island, you might see a rainbow to the east in the morning, and another to the west in the evening, formed by different showers passing on different sides. The ocean provides endless moisture, the sun provides endless light, and the atmosphere mediates between them, creating color again and again. You can photograph a rainbow, but cameras capture it differently than eyes do. The dynamic range of a camera, its ability to record both bright and dark areas simultaneously, is more limited than human vision. Often, to expose the rainbow properly, the rest of the image goes dark, or vice versa. Our eyes balance these contrasts effortlessly, seeing both the bright arc and the subtle details of the landscape below. But even imperfect photographs preserve something valuable. A reminder that the rainbow was there, that the moment happened. That color appeared in the sky, and you witnessed it. Looking at the photo later, you remember not just the rainbow, but the smell of rain, the temperature of the air, who you were with, how you felt. The image becomes a key to unlock the whole experience. And experiences of beauty change us in small ways. Seeing a rainbow doesn't solve problems or answer questions, but it offers a moment of pause, a breath of wonder. In that moment, maybe you remember that the world operates on principles larger than your worries, that light and water will continue to make color whether you're watching or not. That beauty happens without requiring anything from you. So rest now in the knowledge that rainbows are always forming somewhere right now as you breathe slowly and settle into stillness. Rain is falling in some part of the world, and sun is shining, and color is arcing across someone's sky. The universe is doing what it does, creating moments of beauty in the intersection of simple things. You don't have to chase them. You just have to be willing to look up when they appear. The science of rainbows was first truly understood by Isaac Newton in the 1660s. He passed sunlight through a glass prism and watched it separate into colors, then used another prism to recombine those colors back into white light. This proved that white light contained all colors, and that the prism, like a raindrop, was simply revealing what was always there. The rainbow isn't created by water, it's revealed by water. The color was traveling with the light all along. Before Newton, people had theories. Some thought rainbows were reflections of the sun on clouds. Others thought they were painted by angels or cast by precious stones in the sky. Aristotle wrote about rainbows, and so did countless scholars after him, but none quite grasped the complete mechanism until Newton showed how light bends and separates when passing from air into water and back into air again. That bending, refraction, happens because light travels at different speeds through different materials. In air, light moves at about 300,000 kilometers per second. In water, it slows to about 225,000 kilometers per second. When light crosses the boundary between air and water at an angle, one side of the light wave slows down before the other side, causing the light to bend, like a car veering when one wheel hits sand, while the other is still on pavement. Different colors of light bend different amounts because they have different wavelengths. Red light has the longest wavelength and bends the least. Violet has the shortest wavelength and bends the most. All the colors in between bend proportionally to their wavelengths, which is why they separate into that familiar sequence: red, orange, yellow, green, blue, indigo, violet. Roy G. B.A.V., some people say, though indigo is debatable. More on that later. When you see a rainbow, every color you're seeing is coming from different raindrops. The drops that send red light to your eyes are slightly higher in the sky than the drops sending orange. The drops sending violet are lower still. If you could mark each drop with the color it's contributing to your personal rainbow, you'd see they're arranged in bands, hundreds of thousands of drops organized by the angle at which their light reaches you. This means that everyone sees their own unique rainbow. The person standing next to you is seeing light from a completely different set of raindrops, arranged at the same angle from their perspective. You can both describe the same rainbow, point to it, photograph it, but you're literally seeing different phenomena, different collections of water and light organized around different observers. The drops are falling the entire time, remember? So the rainbow you see at one moment is made of different drops than the rainbow you see a second later. It's like a waterfall. The shape stays constant, but the water is always new. The rainbow persists not because any particular drops stay in place, but because new drops keep arriving at the exact angle needed to continue the pattern. Some people have argued that indigo doesn't belong in the rainbow, that there are really only 6 distinct colors. Newton chose 7 because he believed 7 was a harmonious number, like the 7 notes in a musical scale. He wanted his discovery to mirror the mathematical beauty he saw in music. Whether there are 6 colors or 7 or infinite is partly a matter of definition. The spectrum is continuous, and we divide it with words somewhat arbitrarily. Rainbows appear curved because you're seeing all the drops at a specific angle, 42 degrees, from the anti-solar point, which is the point directly opposite the sun from your perspective. Those drops form a cone shape in 3 dimensions, and when that cone intersects with rain falling from the sky, you see an arc. If you could see the rainbow from the side somehow, you'd see that it's actually selecting drops from a cone-shaped section of the rain. Supernumerary rainbows are extra bands of color that sometimes appear just inside the main rainbow. They look like faint pink and green stripes, softer than the main colors, and they happen because light waves interfere with each other after leaving the water drops. When 2 waves align perfectly, they amplify each other. When they're slightly out of sync, they cancel. This creates alternating bands of brighter and dimmer color, a delicate pattern that only appears when the raindrops are very uniform in size. Fog bows are rainbows made by fog instead of rain. The water droplets in fog are much smaller than raindrops, typically less than 50 micrometers in diameter, and they create a different optical effect. The colors overlap so much in these tiny droplets that the bow appears white or pale with just hints of color at the edges. It's sometimes called a white rainbow, and it has a ghostly, ethereal quality, like a rainbow drained of saturation. Moonbows, as mentioned before, are rainbows lit by the moon. They're best seen when the moon is full and low in the sky, and when you're facing rain with the moon behind you. The colors are there in the same order, but moonlight is about 400,000 times fainter than sunlight. So our eyes, which don't see color well in dim light, perceive the moonbow as white or silver. Long exposure photography reveals the colors hidden in the darkness. Some waterfalls are famous for their rainbows: Niagara Falls, Victoria Falls, Iguazu Falls. All of these produce persistent rainbows on sunny days because the water is always falling, always creating mist, always giving light a chance to refract. You can visit these places and see rainbows almost guaranteed. Unlike sky rainbows, which require luck and timing, the spray from a whale's blowhole can create tiny rainbows. When a whale surfaces and exhales, the warm breath hits cold air and condenses into mist. And if the sun is positioned right, that mist briefly refracts light into color. Whale watchers sometimes see these miniature rainbows hovering over the water for just a second or two before the mist dissipates. A small reminder that rainbows appear wherever water meets light, even in the breath of a living creature. Volcanic eruptions can create rainbows in their own steam and ash plumes, though seeing one is rare. The heat and moisture from the eruption combine with sunlight to produce the same refractive effects, but the presence of ash particles can mute or alter the colors. Still, photographers have captured images of rainbows arcing over volcanic craters, color emerging from chaos and heat. Fire rainbows aren't really rainbows at all, and they don't involve fire. The technical name is circumhorizontal arc, and it's caused by sunlight passing through ice crystals in high, wispy cirrus clouds. The crystals need to be plate-shaped and horizontally aligned, which is relatively rare. When conditions are perfect, the ice bends light into a rainbow-like display that appears as a horizontal band of color running parallel to the horizon. It looks like a rainbow lying on its side, stretched across the sky. Halos around the sun or moon are also caused by ice crystals, not water droplets. These appear as rings of light, sometimes faintly colored, at a 22-degree radius from the sun or moon. They're more common in winter or at high altitudes, where ice crystals are more prevalent. If you see one, you're watching light refract through millions of tiny hexagonal ice crystals falling slowly through the air, all oriented in similar ways. Some airplane contrails create colorful displays when sunlight hits the ice crystals in the trails at the right angle. These aren't traditional rainbows, but they use similar principles: light bending through ice instead of water, separating into colors. If you're on the ground looking up, you might see a contrail suddenly flash with color as the plane moves through the exact angle needed for that effect. Auroras, the northern and southern lights, are sometimes confused with rainbows because they involve color in the sky, but they're completely different phenomena. Rainbows are sunlight bending through water. Auroras are charged particles from the sun colliding with gases in Earth's upper atmosphere, causing those gases to glow. One is refraction, the other is luminescence. Both are beautiful, but they speak different languages of light. Polarized light in rainbows can be detected with special filters or sunglasses. The light that forms a rainbow is partially polarized, meaning the light waves vibrate in a specific plane because of how it bounces inside the water droplet. Some animals, including many insects, can detect polarized light and might perceive rainbows differently than we do, though we can only speculate about their subjective experience. The anti-solar point, that spot in the sky directly opposite the sun, is always at the center of your rainbow's arc. If you know where your shadow's head is pointing, you've found the anti-solar point. The rainbow curves around that point at a fixed distance. This is why rainbows appear low in the sky when the sun is high, and high in the sky when the sun is low. The geometry is constant. Only the angles change. In winter, when the sun stays low even at midday, rainbows can appear high in the sky, almost overhead. These high rainbows feel different, more encompassing, less like something you're looking at, and more like something you're standing under. The colors seem to stretch across the dome of the sky, and you have to tilt your head back to see the whole arc. Some rainbows fade gradually, losing saturation and clarity until they vanish. Others disappear suddenly when the rain stops or the sun goes behind a cloud. The ending of a rainbow can feel abrupt or gentle depending on what changes in the atmosphere. But either way, once it's gone, you're left with just the sky again, gray or blue or somewhere in between, and the memory of color that was there a moment ago. And that memory is real. The rainbow was real. The light truly separated into colors. The water truly bent that light. Your eyes truly received those photons and translated them into perception. Nothing about it was illusion or trick. It was physics happening beautifully, in a way you were fortunate enough to witness. Rest in that certainty. The rainbows you've seen were real moments of natural law expressing itself through color, and the rainbows you'll see in the future will be just as real, just as certain, just as governed by the gentle, unwavering rules of light and water. Light doesn't know it's creating beauty. It's not trying to make rainbows. It's simply doing what light does, traveling, bending, reflecting, refracting, and beauty is the outcome. This is one of the quiet miracles of nature. Complex, stunning phenomena emerging from simple rules, followed without intention or awareness. Water doesn't know either. The droplets fall because gravity pulls them. They're spherical because surface tension pulls equally in all directions. They bend light because that's what happens when light crosses from one medium to another at an angle. No raindrop has ever decided to participate in a rainbow. It just falls, and in falling, contributes to something larger than itself. You could say the same about so much in nature. Trees don't try to be beautiful. They grow toward light and develop forms that maximize photosynthesis and structural stability. Flowers don't know they're attractive. Their colors and shapes evolve to attract pollinators. Mountains don't know they're majestic. They're just rock uplifted by tectonic forces and carved by erosion. And yet, all of these things are beautiful to us. We see meaning in the accidental, pattern in the automatic. Maybe that's what makes rainbows so comforting. They remind us that the universe produces beauty as a side effect of its normal operations. You don't have to create beauty intentionally for it to exist. You just have to be what you are, do what you do, and sometimes beauty emerges naturally from the honest expression of your nature. The patience of water is worth noting. Rain can fall for hours, and each drop makes the same journey, condensing around a speck of dust, growing heavy, falling, maybe becoming part of a rainbow, then landing on Earth and beginning the cycle again. Evaporation, condensation, precipitation, over and over for billions of years. Water has been doing this since before life existed on Earth, and it will continue long after we're gone. Each drop in a rainbow has traveled a long way to be there. It might have evaporated from the ocean weeks ago, drifted across continents as vapor, joined a cloud, frozen and thawed, and finally fallen as rain in exactly the right place at exactly the right time to intercept sunlight at the angle that sends color to your eyes. The journey of a single drop is epic in its own small way, and then it lands. It hits the ground or a leaf or a roof, and its role in the rainbow ends. It might join a stream, seep into soil, evaporate again. The rainbow was just a moment in its ongoing cycle, a brief intersection with light during an otherwise unremarkable fall to Earth. But that moment mattered, at least to you watching. Rainbows teach us about perspective. Two people can stand side by side and see different rainbows. Move a few feet to the left, and the rainbow shifts. What you see depends entirely on where you are, what angle you're looking from, what light is reaching your specific position. There's no objective rainbow hanging in the sky that everyone sees the same way. There's only the rainbow that appears for you from where you stand. This is true of so much in life. What you see depends on your position, your perspective, your particular angle on the world. Someone else might be looking at the same situation and seeing something completely different. Not because one of you is wrong, but because you're standing in different places. The light reaches you differently. Some indigenous Australian cultures have stories about rainbow serpents, powerful beings associated with water, fertility, and creation. The rainbow serpent is said to live in waterholes in rivers, emerging during storms. These stories recognize the connection between rainbows and water, and between water and life itself. They're different from European stories about pots of gold or biblical covenants, but they all share a sense that rainbows are significant, meaningful, worth remembering. In Norse mythology, Bifrost is a rainbow bridge connecting Earth to Asgard, the realm of the gods. Warriors who died bravely would cross this bridge after death. The rainbow is a pathway, a connection between worlds, a way of moving from one state to another. It's a beautiful metaphor, crossing from earth to sky, from mortal to divine, walking on light itself. Irish folklore speaks of leprechauns hiding pots of gold at the end of rainbows. It's a story about impossibility disguised as possibility. You can chase the rainbow, but you'll never reach the end because it moves with you. The treasure is always just beyond reach. Maybe the real treasure is the chase itself, the hope, the movement through a landscape made beautiful by recent rain. In some parts of the world, people believe that pointing at a rainbow is unlucky or disrespectful. Others believe you should make a wish when you see one. Still, others simply stop and watch, feeling no need to do anything except acknowledge the moment. All of these responses honor the rainbow in different ways, through silence, through hope, through respect for something larger than themselves. Children often shout when they see a rainbow. There's an unguarded joy in the reaction, an excitement that adults sometimes lose. Underscore, quote, underscore, zero. Underscore, they yell, pointing, making sure everyone else sees it too. They haven't yet learned to be casual about beauty, to take wonders for granted. Every rainbow is still new to them, still surprising. Maybe we should preserve some of that. Maybe even as adults, we can let ourselves feel a small spark of joy when colors arc across the sky. Not because we don't understand the science. Understanding doesn't diminish wonder, but because beauty is still beautiful, even when you know how it works. Maybe, especially then, some people photograph every rainbow they see, building collections of rainbow images on their phones or cameras. Each one is slightly different. Different locations, different times of day, different weather, different landscapes. Together, they form a personal history of moments when conditions were exactly right, when the person happened to be looking in the right direction, when the world offered color and they were there to receive it. Others never photograph rainbows, preferring to just watch. They don't want the distraction of framing and focusing. They don't want to see the rainbow through a screen. They want the direct, unmediated experience of color in sky, of light doing something beautiful right in front of them. Both approaches are valid. Both are ways of honoring the moment. Sometimes you see a rainbow while driving, and it paces you on the horizon, appearing and disappearing as you move through landscape and weather. It's there in the distance, then gone behind trees, then visible again across a field. You're moving through space. The rain is moving through space. The light is constant, but your angle to it keeps changing. The rainbow flickers in and out of existence from your perspective, though from another perspective, say, someone stationary on a hill, it might be completely steady. Everything is relative. Everything depends on where you are and how you're moving and what you're paying attention to. The rainbow doesn't change, but your ability to see it does, constantly, based on factors both within and beyond your control. And maybe that's okay. Maybe you don't need to see the rainbow every moment. Maybe the glimpses are enough, flashes of color between trees, brief arcs visible through gaps in clouds, moments of beauty that come and go and come again. Maybe the impermanence is part of what makes it special. If rainbows lasted forever, we'd stop noticing them. They'd become background, like the blue of the sky. It's their temporary nature that makes them precious. They appear, they exist for a little while. They vanish, and in that vanishing, they leave us with a memory of color and light, a reminder that we witnessed something that won't come again in exactly the same way. So, breathe slowly. Let the thought of rainbows settle through you, the science and the stories, the light and the water, the colors that appear and disappear according to laws older than humanity. Let yourself rest in the knowledge that somewhere, right now, a rainbow is forming. And somewhere, someone is seeing it for the first time. And somewhere, someone is seeing their 1,000th rainbow and still finding it beautiful. You are part of this continuity. You are a witness to light, a receiver of color, a person standing in the right place at the right time, looking up, seeing what's there to be seen. And that's enough. That's always been enough. The physics of rainbows extends into realms we rarely consider. Quantum mechanics plays a role, though it's subtle. Light behaves both as a wave and as a particle. Photons with wave-like properties. When light refracts through a water droplet, we can describe it with wave equations that predict exactly where the colors will appear and how bright they'll be. The same photon that left the sun arrives at the raindrop, bounces inside, exits, and travels to your eye, all while maintaining its identity as a discrete packet of electromagnetic energy. But you don't need to think about quantum mechanics to appreciate a rainbow. You can know nothing about physics and still feel something when you see one. The beauty doesn't require understanding. It's available to everyone, the scientist and the child, the educated and the illiterate, the person who can explain refraction and the person who simply sees color and feels glad. Some animals definitely see rainbows, though we can't know exactly what they perceive. Any creature with color vision and eyes positioned to catch the light would register the spectrum. Birds, certainly. Some mammals. Many insects have compound eyes and can see colors humans can't, including ultraviolet. They might see rainbows with additional bands of color invisible to us, strange hues with no names in our language. Other animals probably don't notice rainbows at all. Most mammals have limited color vision. Dogs and cats, for instance, see fewer colors than humans. To them, a rainbow might look like a vague variation in brightness, gray tones arcing across the sky. Nothing special. They'd have no reason to stop and stare. The beauty is lost on them not because they're deficient, but because their eyes evolved for different purposes. They see what they need to see. Even among humans, color perception varies. About 8% of men and 0.5% of women have some form of color blindness, usually difficulty distinguishing reds and greens. For them, a rainbow has fewer distinct bands. The colors might blend together differently, creating a different spectrum. They're still seeing something real, but their experience of it is uniquely their own, different from the standard rainbow described in textbooks. Some people have a condition called tetrachromacy. They have 4 types of color receptors instead of the usual 3. This is rare and mostly found in women, and it means they can distinguish between colors that look identical to the rest of us. A tetrachromat looking at a rainbow might see subtleties no one else can, gradations within gradations, nuances of hue that the rest of us perceive as uniform. They'd have trouble describing what they see because we don't have words for colors that most people can't detect. All of this reminds us that reality is filtered through our senses, and our senses are just one way of accessing information about the world. The rainbow exists independent of whether anyone sees it. Light bends through water whether or not eyes are present to receive it. But the experience of the rainbow, the qualia, as philosophers call it, the subjective sensation of seeing color that happens in consciousness, in the mind's interpretation of signals from the eyes. We can measure the wavelengths of light in a rainbow, red around 700 nanometers, violet around 380 nanometers. We can predict exactly where each color will appear based on the angle and the refractive index of water. We can photograph it, analyze it, quantify it in every possible way. But the experience of seeing red, the feeling of what it's like to perceive That particular wavelength has that particular color that remains private, ineffable, impossible to fully communicate or confirm. Maybe the person standing next to you sees red entirely differently than you do. Maybe what they call red looks like what you'd call blue, but they learn to call it red because that's what everyone calls light of that wavelength. We have no way to compare subjective experiences directly. We can only point at wavelengths and agree on labels. The inner experience remains mysterious. Rainbows don't mind any of this. They form according to physical law, indifferent to how many eyes see them or how those eyes interpret the light. The rainbow does its thing whether you're paying attention or not, whether you understand it or not, whether you're capable of seeing it or not. It's one of those phenomena that exists entirely for itself, owing us nothing, giving us everything. The water in a raindrop that contributes to a rainbow might be thousands of years old, or it might have evaporated from the ocean yesterday. Water cycles through the atmosphere relatively quickly, an average of 9 days from evaporation to precipitation. But individual water molecules are ancient, recycled endlessly since Earth's formation. The hydrogen atoms in water were created in the Big Bang. The oxygen came from dying stars. So the water bending light into your rainbow is literally made of stardust, remnants of cosmic events billions of years ago. Every rainbow is built from ancient materials. The light is fresh, 8 minutes from the sun, but the water is old beyond measure. New light, old water, meeting in the present moment to create color, past and present combining briefly before separating again. The water will fall to earth and enter the cycle once more. The light will be absorbed or reflected, its energy transforming into heat or chemical bonds, or the firing of neurons in your brain as you register what you've seen. Nothing is wasted. Energy is conserved. Matter is conserved. Everything transforms, but nothing disappears. The light that didn't form the rainbow did something else, warmed the ground, enabled photosynthesis, reflected off a building. The water that didn't catch light in quite the right way still contributed to the rain, still watered the earth, still served its purpose. In this way, a rainbow is just one possible outcome of light and water interacting. It's special to us because we perceive it as beautiful, but from the universe's perspective, it's no more or less important than any other interaction. The rainbow and the non-rainbow, the light that bends and the light that doesn't, all equal participants in the ongoing flow of energy and matter through space and time. And yet, we're allowed to find it special. We're allowed to stop and watch and feel something warm in our chest when we see colors arc across the sky. Our subjective experience is real, even if it's not objectively more significant than anything else. We're part of the universe observing itself, finding meaning and beauty in our own processes. Rainbows have appeared in art for thousands of years. Cave paintings from the Paleolithic period sometimes show arcs that might be rainbows, though it's hard to be certain. Medieval manuscripts depict them in religious scenes. Renaissance painters included them in landscapes. Modern artists abstract them, deconstruct them, reimagine them. The rainbow as symbol, as motif, as inspiration. The rainbow flag adopted by LGBTQ+ communities uses the rainbow spectrum to represent diversity and inclusion. It takes a natural phenomenon and assigns it cultural meaning, transforming it into a symbol of identity, and pride. This is what humans do. We see patterns in nature, and we make them mean things. We layer significance onto the physical world. We create narratives from observations. Rainbows mean different things to different people. Freedom, hope, promise, diversity, wonder, connection between earth and sky, between human and divine, between present and future. Or they mean nothing at all, just pretty colors, a pleasant sight, a momentary distraction from daily concerns. All of these are valid. The rainbow supports whatever meaning you bring to it. Scientifically, a rainbow is just an optical phenomenon. Culturally, it's whatever we make it. And personally, individually, it's whatever you feel when you see one. There's no right answer. There's no incorrect way to experience a rainbow. You can analyze it or simply enjoy it, photograph it or ignore it, make a wish or just keep walking. The rainbow doesn't judge. The gentleness of a rainbow is part of its appeal. It's not dramatic like lightning or thunder. It doesn't demand attention the way an eclipse does. It appears quietly, almost shyly, and if you're not looking, you'll miss it. But if you are looking, if you happen to turn your head at the right moment, there it is, color hanging in the air, soft and steady, asking nothing of you. That softness is rare in a world that often feels loud and harsh. The rainbow offers respite. It gives you permission to pause, to look up, to notice something beyond your immediate concerns. For the minutes it lasts, you can let everything else fall away and just be present with color and light. And when it fades, you can return to your life carrying a small gift, the memory of having seen something beautiful. That memory is yours to keep. No one can take it from you. It becomes part of your internal landscape, a moment of peace you can revisit when you need it. So imagine that rainbow now, in whatever form brings you the most comfort. Maybe it's a full arc over mountains. Maybe it's a faint bow over the ocean. Maybe it's a small rainbow in a garden sprinkler on a summer afternoon. Whatever it is, see it clearly in your mind. Let the colors settle into you, red and orange and yellow and green and blue and indigo and violet, each one soft and true. Breathe with the rainbow. Let it remind you that beauty exists, that light and water still make color, that some things in this world are gentle and predictable and free. You're safe here, thinking of rainbows. Let yourself rest. The atmosphere itself plays a role in how rainbows appear. Air isn't perfectly uniform. It has layers of different temperatures, different densities, different amounts of moisture. Light traveling through the atmosphere bends slightly as it passes through these layers, a phenomenon called atmospheric refraction. This is why the sun appears slightly higher in the sky than it actually is when it's near the horizon. The same effect influences rainbows, though in subtle ways most people wouldn't notice without instruments. On days with very clear air, after a storm has washed away dust and pollution, rainbows can be exceptionally crisp and saturated. The light travels through cleaner atmosphere, encounters purer water droplets, and the resulting spectrum is more vivid. These are the rainbows that make you stop mid-sentence, that pull your attention completely away from whatever you were doing. They almost seem to glow against the gray clouds. Conversely, in areas with heavy air pollution, rainbows can appear muted. Particles in the air scatter light before it reaches the raindrops, and scatter it again after it leaves them. Some wavelengths are scattered more than others, which can shift the colors slightly or reduce their intensity. The rainbow is still there, following all the same rules, but it has to fight through interference to reach your eyes. Desert rainbows, when they do occur, often have a particular clarity because desert air tends to be very dry and clean. The rain that falls has usually traveled a long distance to reach the desert, and it falls through air with minimal moisture and few particles. The resulting rainbows can be startlingly sharp, each color band distinct, the whole arc standing out against dramatic storm clouds in high contrast landscapes. Tropical rainbows happen in humid air, heavy with moisture. Sometimes you can see the rain falling in sheets in one direction while the sun shines from another, and the rainbow forms in the space between. The air feels thick, warm, alive with water vapor, and the rainbow seems to emerge from that thickness, a clarification of the air itself into visible color. Arctic and Antarctic rainbows are rare because precipitation usually falls as snow at those temperatures, but they can occur during brief warming periods or in coastal areas where rain still falls. The light in polar regions comes in at extreme angles for much of the year, creating conditions for very wide, very low rainbows. And in summer, when the sun circles the horizon without setting, you might theoretically see rainbows at times we'd normally call night, formed by sunlight that's grazing across the world at midnight. High-altitude rainbows, seen from mountains or airplanes, often appear brighter and more complete than those seen at sea level. You're above much of the atmosphere, so there's less air to scatter and dim the light. You're also more likely to see full or nearly full circles because you can look down at rain falling below you, seeing the rainbow from above rather than from the side. Some pilots report seeing rainbows that follow their aircraft, staying in the same position relative to the plane as they fly through or near rain. This happens because the anti-solar point moves with the observer. As the plane moves, the geometric relationship between sun, rain, and observer stays constant. So the rainbow appears to travel along, always the same angle from the aircraft's shadow on the clouds below. The shadow of a plane on clouds sometimes appears surrounded by a glory, a series of colored rings that look similar to a rainbow, but are created by a different mechanism. Light diffracts around water droplets and interferes with itself, creating concentric circles of color. If you're in the plane looking down at this, you see your shadow, or the shadow of the plane you're in, ringed with color, a personal halo traveling across the cloudscape. These optical phenomena remind us that light is constantly doing interesting things all around us. Most of it goes unnoticed. We see the bright, obvious rainbows, but we miss the subtle halos, the fleeting iridescence in clouds, the faint arcs of color that appear and vanish in moments. The world is full of light-based beauty that exists at the edge of perception, waiting for the right eyes and the right attention. Ice crystals create their own spectrum of optical phenomena. Sundogs appear as bright spots on either side of the sun created by light, refracting through hexagonal ice crystals. Halos form at specific angles when light passes through ice in certain orientations. Pillars of light can extend above or below the sun or moon when plate-shaped ice crystals act like tiny mirrors. Each of these requires specific atmospheric conditions, specific crystal shapes, specific angles of light. Compared to these ice-based phenomena, water rainbows are relatively common and straightforward. They need only liquid water, sunlight, and an observer in the right position. The water doesn't need to be shaped in any particular way. Any spherical drop will work. The sun doesn't need to be at a specific altitude. Anywhere from just above the horizon to relatively high in the sky can produce rainbows. The requirements are simple, which is why rainbows appear more often than most other atmospheric optical phenomena. But simple doesn't mean uninteresting. The elegance of rainbows lies partly in their simplicity. Complex rules produce them, but those rules operate consistently. There is no randomness in where the colors appear, no uncertainty about the arc's radius, no mystery about why red is outside and violet inside. Everything follows from basic principles of optics, working the same way every time. This reliability is comforting. In a world where so much feels chaotic and unpredictable, rainbows follow rules. Light bends through water at predictable angles. Colors separate in invariant sequence. The 42-degree radius holds constant. You can trust a rainbow to be what it is, to behave as light and water always behave when they meet. Some spiritual traditions see rainbows as signs or messages, a promise from the divine, a bridge between worlds, an omen of good fortune. Even if you don't hold these beliefs, there's something to be said for the idea that rainbows mean something, that they serve a purpose beyond mere physics. They remind us to look up. They interrupt our routines. They bring us briefly into the present moment, alert and attentive. In that sense, maybe rainbows do carry messages, just not supernatural ones. They remind us that beauty exists, that the world operates on principles we can understand, that the same rules produce the same outcomes, reliably, trustworthily, that light and water have been making color for billions of years and will continue to do so, that we are small and temporary, but we are here, now, capable of seeing color in the sky. The transience of rainbows mirrors our own transience. They appear, they last a little while, they fade. We do the same. Everything does. The universe tends toward entropy, toward dispersal, toward the evening out of gradients and the fading of structures. But in the meantime, rainbows happen, life happens, consciousness happens, meaning happens, even if it's temporary, even if it vanishes, even if it leaves nothing permanent behind. Maybe the impermanence is the point. Maybe beauty matters more because it's temporary, because it can't be held or kept, only witnessed and remembered. The rainbow teaches us to appreciate what's here now, knowing it won't last, finding joy in the momentary, rather than mourning its inevitable end. When you were a child, did you ever try to catch a rainbow? Run toward it, thinking maybe this time you could reach it, and then discover it had moved, that it was always the same distance away no matter how fast you ran. That experience, the chase, the impossibility, the lesson in physics disguised as play, that's a gentle introduction to acceptance. Some things can't be grasped. Some things can only be witnessed. And witnessing is enough. Maybe more than enough. Maybe witnessing, truly seeing, being fully present with something beautiful. Maybe that's one of the most meaningful things we can do. Not capturing, not possessing, not documenting for later, but just being there, eyes open, heart open, receiving what's being offered. So let yourself be a witness now, not to an actual rainbow, but to the idea of rainbows, to the possibility of them, to the physics and poetry of color in the sky. Let yourself rest in the knowledge that rainbows exist, that they've existed for as long as Earth has had rain and sun, that they'll continue to exist long after you're gone. Let that continuity comfort you. You're a part of a long tradition of witnesses. Countless humans have seen what you've seen, felt what you've felt, stopped and stared and wondered at color arcing overhead. You're connected to all of them through this shared experience, this common moment of noticing beauty in the intersection of light and water. Breathe slowly. The rainbow in your mind is as real as the rainbow in the sky, in the sense that both are patterns of neuronal firing, interpretations of stimuli, experiences happening in consciousness. You can rest in color even with your eyes closed. Red and orange and yellow and green and blue and indigo and violet, soft and present, asking nothing, offering everything. Some scientists dedicate their careers to studying atmospheric optics, the way light behaves in air, in clouds, in rain, in ice. They measure rainbows with the spectroradiometers, devices that precisely record the intensity of each wavelength of light. They create mathematical models predicting exactly how rainbows will look under different conditions. They publish papers with titles like, quote, 1 or quote, 2. This level of detail might seem excessive. We can see rainbows just fine without understanding their spectral distribution or polarization characteristics. But the scientists aren't studying rainbows to make them more beautiful. They're beautiful already. They're studying them to understand light, to test theories of optics, to probe the fundamental ways that electromagnetic radiation interacts with matter. The rainbow is a laboratory, a natural experiment happening in the open air, free for anyone to observe and analyze. From these studies, we've learned subtle things. The width of each color band depends on the size distribution of raindrops. Narrower bands mean more uniform drop sizes. The brightness depends on how many drops are present and how dark the background is. The presence of supernumerary bands reveals information about droplet size with incredible precision. You can estimate the average diameter of raindrops to within a few micrometers just by looking at the pattern of pink and green fringes. Weather radars can detect rainbows, in a sense. They send out pulses of microwave radiation and measure what bounces back. When rain is organized in the specific geometry that creates a rainbow, the radar signature looks different. There's a distinctive pattern called a bright band that appears at certain angles. Meteorologists can use this to understand precipitation structure, though they're looking at microwaves, not visible light. The principle is similar. Radiation scattering off water droplets in particular arrangements. All this technology and analysis, and yet the fundamental experience of seeing a rainbow hasn't changed. A person 10,000 years ago saw essentially the same thing you see now. The human eye hasn't evolved significantly in that time. The physics of light and water haven't changed. The rainbow they saw and the rainbow you see are connected by unbroken physical law, identical in form and origin. This is one of the few experiences we can be certain we share with our ancestors. Most of their world is unimaginably different from ours. Their lives, their concerns, their daily experiences are alien to us. But they saw rainbows. They looked up after rain and saw color in the sky. They might have interpreted it differently, woven different stories around it, but the visual experience itself was the same. Light, water, eyes, brain, these haven't changed. Some animals might have better rainbow experiences than we do. Birds with 4-color vision see more colors than we can. Mantis shrimp have 16 types of color receptors compared to our 3. If they looked at a rainbow, assuming they ever look up at the sky, which they probably don't, being aquatic, they might see bands of color we can't even imagine. Color beyond our spectrum, hues with no names, a rainbow richer and stranger than anything we've experienced. But we'll never know. We're trapped in our own perceptual apparatus. We can build instruments to detect ultraviolet and infrared. We can mathematically model what other visual systems would perceive, but we can't directly experience seeing like a bird or a bee or a mantis shrimp. Our qualia are ours alone, bounded by the particular configuration of neurons and photoreceptors we possess. Still, the rainbow we do see is beautiful enough. We don't need to see ultraviolet to appreciate red. We don't need 16 color channels to find joy in 7. Our human rainbow, perceived through human eyes, experienced in human consciousness, is sufficient. It's more than sufficient. It's wonderful. Children paint rainbows with the wrong number of stripes, or the wrong colors, or in impossible locations. Rainbows coming up from the ground, or spiraling, or with purple and pink and other colors that don't appear in actual spectra. These paintings aren't wrong exactly. They're interpretations, expressions of how rainbows feel rather than how they physically are. The child knows the rainbow is special, knows it's colorful, knows it appears in the sky. The details don't matter. The feeling does. As we grow older, we learn the correct order of colors, the proper arc shape, the physics. But maybe we lose something in gaining accuracy. The child's rainbow is joyful, unbounded by physical law. The adult's rainbow is correct, but sometimes less emotionally vivid. We gain knowledge and lose wonder, or at least we risk that trade-off. But it doesn't have to be that way. Knowledge and wonder aren't mutually exclusive. You can understand refraction and still feel awe. You can know the wavelengths and still find the colors beautiful. Understanding doesn't diminish beauty. It just adds another layer of appreciation. Now, you're marveling not just at the rainbow, but at the elegant simplicity of the laws that produce it. Some people chase rainbows as a hobby. They track weather patterns, watch radar, position themselves where rain and sun are likely to coincide. They travel to places known for frequent rainbows: Hawaii, parts of the Pacific Northwest, certain tropical islands. They collect photographs of rainbows over different landscapes, in different lights, at different times of day. Their hard drives fill with images of color arcing over mountains, oceans, forests, deserts. Why? What drives someone to pursue rainbows so deliberately? Maybe it's the beauty. Maybe it's the challenge of being in the right place at the right time. Maybe it's the way rainbows force you outside, into weather, into direct contact with the natural world. You can't see rainbows from inside most of the time. You have to go out, stand in or near the rain, accept that you'll get wet. The rainbow rewards you for that small courage. Other people might see dozens of rainbows without really registering them. They're busy, distracted, focused on other things. The rainbow appears, and they might glance at it, acknowledge it briefly, then return to their thoughts. They're not wrong to do this. Not every beautiful thing deserves full attention every time. Sometimes a quick glance is enough. Sometimes beauty can be background. But occasionally, it's worth stopping, putting down the phone, stepping away from work, just standing and looking at the rainbow for as long as it lasts, giving it your full attention, your complete presence. These moments of deliberate witnessing are gifts you give yourself. They create memories that last longer than the rainbow does. The rainbow doesn't care whether you look or not. This is important to remember. It's not performing for you. It exists regardless of your attention. The light bends through water, following physical law, and whether 0 people or 1,000,000 people witness the result makes no difference to the light or the water. The rainbow is indifferent to your presence, and yet, in another sense, the rainbow only exists because you're looking. Not the physical phenomenon, that's happening regardless. But the rainbow as experience, as color, as beauty, that requires consciousness. Without someone or something to see it, the rainbow is just wavelengths of light traveling through space. Seeing transforms those wavelengths into experience, into meaning, into something that matters. This is the strange loop of consciousness. The universe produces phenomena. Consciousness observes phenomena and experiences them as something more than mere physics. Then consciousness wonders about its own role in creating that experience. And around and around. The rainbow is just light. The rainbow is also beauty. Both are true. Neither is more true than the other. They're different levels of description, different ways of talking about the same event. Philosophy aside, what remains is this. When you see a rainbow, something happens inside you. Neurons fire in patterns. Your brain constructs an image from signals sent by your eyes. You recognize it as a rainbow, connect it to memories of other rainbows, perhaps feel a small lift in mood. All of this is biology, neurochemistry, physics, and all of it is also experience, qualia, subjective reality. Let yourself rest in that dual nature. You are a physical being, neurons and chemicals and electrical impulses. You are also an experiencing being, consciousness and feeling and awareness. The rainbow speaks to both its photons and refractive indices. It's also beauty and wonder and momentary joy. Both aspects are real. Both matter. Breathe slowly now. Feel your body breathing, that automatic process of drawing air into lungs, extracting oxygen, expelling carbon dioxide. It happens without your conscious control, governed by your brainstem, regulated by blood chemistry. Pure biology. And yet, you can feel it, be aware of it, experience it as something more than mere respiration. You're always both. Mechanism and consciousness, object and subject, thing and experiencer. The rainbow reminds you of this. It exists out there, independent of mind. It also exists in here, dependent on mind. Both rainbows are real. Both deserve acknowledgement. You are the bridge between them, the place where external phenomenon becomes internal experience, where physics becomes feeling, where the world enters consciousness and is transformed. And in that transformation, in that moment of seeing and being aware that you're seeing, something meaningful happens. Not earth-shattering, not life-changing, just meaningful in a quiet way. A moment of connection with the world, a brief alignment of attention and beauty, a small reminder that you're alive and capable of perceiving color in the sky. That's enough. That's always been enough. The rainbow asks nothing more of you than to be present with it, to see it, to let it exist in your awareness for the brief time it lasts. And when it fades, you can carry the memory forward, not desperately, not clinging to it, but gently, letting it settle into the collection of all the other beautiful things you've seen, all the other moments of color and light that have visited your life. You're building a library of beauty, one rainbow at a time. So now, let the rainbow in your mind begin to soften, not disappearing suddenly, but fading the way real rainbows fade, gradually, gently, the colors becoming lighter, more translucent, blending back into sky. The red softens first, then orange, then yellow, each color releasing its intensity, becoming pastel, becoming suggestion, becoming memory. The arc remains visible a little longer, a faint outline of where the colors were, like the afterimage of something bright. And then even that fades, and you're left with just sky, peaceful, gray or blue, soft and infinite above you. The rainbow is gone, but you're not sad. You watched it while it lasted. You were present with it. You gave it your attention, your awareness, your appreciation, and now it's gone, which is exactly what rainbows do. They come and they go, and both the coming and the going are part of their nature. You can rest now, knowing that rainbows will continue to appear somewhere in the world, that light and water will keep making color whether you see it or not, that the universe continues its ancient patterns without needing your participation or permission. You witnessed beauty today, in your mind, if not in the sky. You spent time in the presence of color and light and the gentle certainty of natural law. You allowed yourself to slow down, to breathe, to imagine something peaceful and true. That's a gift you gave yourself. The rainbow was the invitation, but you accepted it. You chose to be here, to read these words, to picture rainbows in your mind, to let yourself rest in the soft knowledge that beauty exists and will continue to exist. Thank you for being here. Thank you for paying attention. Thank you for allowing yourself this time to rest. With rainbows, with light, with water, with the quiet spaces between thoughts where peace lives. The rainbow has faded now, but the peace remains. Let it stay with you as you drift toward sleep or simply toward deeper calm. Let the colors linger in your memory, red and orange and yellow and green and blue and indigo and violet, soft and safe, asking nothing, offering everything. Close your eyes if they're not already closed. Feel the weight of your body resting wherever you are. Notice your breath, slow and steady, requiring no effort, just happening naturally, the way rainbows happen naturally when conditions are right. You're exactly where you need to be. There's nothing you need to do, nowhere you need to go, nothing you need to figure out or fix or change. Just this, breathing, resting, being present in this moment of quiet. The world will still be there tomorrow. The rain will fall again. The sun will shine again. And somewhere, sometime, another rainbow will arc across the sky, waiting for eyes to see it, waiting for consciousness to recognize it, waiting to remind whoever witnesses it that beauty still happens, that light still bends through water, that some things remain constant even as everything changes. But that's tomorrow's rainbow, or next week's, or next year's. Right now, there's only this, the soft darkness behind your eyelids, the gentle rhythm of your breathing, the quiet stillness settling through your body like mist settling into a valley. You are safe. You are peaceful. You are exactly enough, exactly as you are in this moment and every moment. Rest now in the soft afterglow of imagined rainbows, in the gentle certainty that beauty exists and will find you again when the time is right. Let yourself drift, soft and easy, like a droplet of water falling through calm air, like light traveling through space. like color fading from the sky as day turns to dusk. Everything is well. Everything is peaceful. Everything is exactly as it should be. Rest now. Just rest. And sleep.
Bye bye.